Okay, good morning. Welcome to
SuperMath number 96.
SuperMath96. So today you were taking a look at the 2011 AMC 10B, and this problem. Sorry, I got it clear. Couldn't see it. Number 13 caused you to have some questions, and they're great questions. Two real numbers are selected independently at random from the interval -20 to 10. What is the probability that the product of the numbers is positive? Interesting. Okay. What are some thoughts you had about this problem?
Well, how am I supposed to find the probability when you have real numbers? There's infinitely many real numbers in this interval.
Good question. So how do we usually think about probability?
Well, it's usually what we want, the good outcomes, over the total outcomes.
Okay.
But we'd have infinitely many of both.
Yeah. Huh. So we got to figure out a different way to think about this, because there must be some way to think about it, only because you think they would have snuck in some weird questions about infinity on a math contest for 10th graders?
Probably not.
Probably not, but maybe they did. Okay. This question you're wondering about confused a lot of people for a really long time. And then, in fact, I just thought about this right now. After this movie, we'll do a second movie about one of the most famous weird probability problems that you'll ever see. Okay? So this is from a type of probability that's different than what you're used to. We're used to doing probability with like snap cubes or like discrete items where we can count the good cases, count the total cases. This is from an area of probability called geometric probability, where instead of counting the good cases and the total cases like on our fingers, or they're discrete, what we're going to use is the length of the line segments that work. Okay, so I have sorry, this is the bad marker. -20. I have this interval -20 to 10. Okay. What do I need to do to make the product of the numbers positive?
Well, you either need both of them negative or both of them positive.
Right, so I have two totally different cases. I have negative, negative, and I have positive, positive. Okay, and it says they're selected independently at random. Okay, so however I select the first one doesn't affect how I select the second one. Okay? Can you show me where 0 is on my number line here? If this is minus, and so make it approximately right.
It would be closer to 10.
Okay.
I'm gonna say it's about there.
All right. How long is this line segment here from -20 to 0?
It would be 20 long.
How long is this line segment?
It would be 10 long.
So what do you think, if we select a number at random from this line, from -20 to 10, what do you think the probability is that it'll be negative?
Probably 2/3.
How come?
Because you have, this is 10 long, and this is 20 long. The whole thing is 30 long.
Yeah?
And then, what we want, the good outcomes, there's 20, because it's 20 long.
There you go. Okay.
2/3.
So the probability that I pick my first number negative is 2/3. How about the second number?
Well, it would also be, if the second number, the probability is negative is also 2/3.
Yeah. So what's the probability that the product is positive given that both numbers are negative?
It's 4/9.
4/9. Oh, sorry, I actually said that wrong. Given that both numbers are negative, the probability that the product is positive is 100%. Right? So I went to ask, what's the probability of picking both numbers being negative? Sorry, I just misspoke. Now let's go to positive, positive.
Well, it's a 1/3 chance.
Okay. 1/3 of picking the number positive. The first one, how about the second one?
1/3.
1/3. So what's the probability of picking two positives?
It's 1/9.
1/9.
So it's
because I have these two independent cases.
So, but the whole thing would be 5/9.
5/9. Okay. So it's actually greater than a half. that they're and that's has to do with the fact that you're more likely to pick negative negative 4/9 of the time, positive positive. What do you call it?
1/9 of the time.
1/9 of the time. There you go. So 5/9 is the answer. Now, does that make sense?
Yeah.
You see how we had the good cases and the total cases? But
Yeah.
we looked at it in terms of length this time. Seems like it makes sense. But now we're going to, just for fun, move on to a really weird probability problem that shows that your objection about having these infinities is exactly right. Okay.